Welcome back. Now it's time to prove the Clausius inequality in its general form. I didn't do this derivation directly because this derivation is in the domain of differential calculus. Let us state what we want to prove. Let us say that we have a system and it executes a cyclic process. Let us say that during some part of the cycle, the heat interaction from some neighboring system is dq, and the temperature here where that heat interaction takes place is T, and the work done through the cycle is W. So, since work done is for the whole cycle, to apply the first law we will have to say the work done must be integral of dq, and what we want to prove is the Clausius inequality, that integral of dq by t over the cycle is less than or equal to 0. And to prove this, again we will use the trick of reductio ad absurdum, and we will say that let us assume that this integral of dq by t is greater than 0. And now we proceed as earlier. Let us have a reservoir T naught which would run to provide this dq a reversible machine R, which would extract from this reservoir dq naught, provide this dq to the system, and the work would be dw naught. So, this is the scheme. Now, remember that this is a reversible 2T machine. So, we have dw naught is dq naught minus dq by first law. Then algebra, write this as dq into dq naught by dq minus 1, and which, because this pertains to a reversible machine, this will be dq into the temperature at which heat is supplied to this reversible machine, that is T naught divided by the other temperature T1 minus 1. Now, let us consider this as a system. What is this? This is a 1T machine, and which is cyclic. Why cyclic? Because the system is part of our machine, it is cyclic, and all these reversible machines as required to provide this dq are also cyclic. So, our extended system shown by dotted line here, the dotted loop here, is a 1T machine which executes cyclic processes. And what is the work output of this 1T machine? The work output is W plus integral of all these dw naughts, which is W plus integral of, let me write it as T naught minus. Now, this can be written down as W plus T naught cyclic integral of dq by t minus cyclic integral of dq. And from this equation we know that w equals this cyclic integral, so that cancels out. So this becomes T naught into integral of dq by t, which turns out to be greater than 0 with our assumption. But this violates the second law of thermodynamics as represented by the Kelvin-Planck statement, and the only way we have violated it is by assuming this to be true, and that means this assumption is false. So this is a violation of the second law, and hence this assumption is false, and hence our Clausius inequality is proved. So this was the general proof of the Clausius inequality. Thank you.